This is my fourth video in my module on graphing trig functions. In this one, we're still going to explore the effects of A and B on the graphs of, say, sine and cosine, but this time we're going to take an approach where we explore cosecant and secant graphs, which are the reciprocals, okay, the reciprocals of just the sine and the cosine curve. So I'm going to start by saying this. If you know how to graph a sine and a cosine curve, regardless of the A or the B value, then you know how to graph its reciprocal function. We'll talk about why. I'll start with a few basics, though. We say the period of the graphs of y equals a cosecant bx and a should be a secant bx. The period is 2 pi over b. So this is just very much the same thing as the period of a sine or a cosine curve because they are the reciprocals of sine and cosine respectively. They have the same period. You'd find it by taking 2 pi over b. It is important to note that these graphs will not have an amplitude. Recall that amplitude, when it comes to amplitude, we say it's really just half of the distance between the max and the min. And so when we're graphing reciprocal functions would tend to look like this. Okay, they come down and they touch the curve like this. They never stop going up or down. So we'd say, since they don't have a max or a min, they have no amplitude. That's very important. And then last but not least, we'll talk about the range here, but we say the range is all y values greater than the absolute value of a and all y values less than the negative, whatever the absolute value of our a value is up front here, okay? So we're going to go ahead and just take a look at this example. I think that's the best way to kind of approach this is just do an example. We say graph the following function on the interval from x equals 0 to 2 pi. We want to identify the amplitude if it exists. It does not exist, recall. The period and the domain or range. But here's what I want to say. If somebody ever asks you to graph y equals 3 secant 2x, what I'm going to tell you is this. Let's just graph its reciprocal function. You know why? Because I know what this looks like, y equals 3 cosine 2x. So we're going to start by graphing this one in blue. And once we get this one in blue, then we'll go back and we'll sketch in this graph here, which is its reciprocal function. So if my job is to graph this one in blue, I actually can identify a few things. We say, well, first of all, the a value is 3, and the b value on the inside here, this is b, is 2. So we get a few things from this. We say the amplitude of the cosine graph would equal the absolute value of 3, which is just 3. And we say the period now, which is 2 pi over b, 2 pi over b. In this case, b being 2, we say the period then would be pi. So knowing these things and keeping them in our back pockets, we could say, all right, so I want to sketch this in blue. I'll drop my axes in green. Recall that when you make a trig function, we always go out one period past 0. In this case, the period is pi. So we say pi. We're going to take this period and we're going to quarter it. So it means split it in half. We're always going to label this halfway mark as this case, pi halves. And then we're going to quarter those. We say in this case the amplitude is 3. So we'll go up 3, and down 3. 1, 2, 3. Fair enough. And then we say, well, okay, well, what's the basic shape of the cosine curve look like? Recall that the basic shape of the cosine curve looks like this. So at the beginning of its period, when we plug in x equals 0, it starts up at its maximum, proceeds down to ground level here. Halfway through its period, it's down at its minimum. 3/4 of the way through its period, it's back up to ground level. And then we say all the way through its period, now it's at its maximum again. So we say this is our cosine graph. Now recall that this is not the one we set out to sketch, and I don't think I did a very good job there, and I don't think I'm doing much better on that one. Yikes, man. Thanks for being patient with me. I'm a little bit obsessive compulsive. Okay, so here's our cosine curve. It looks somewhat like this. The things I want to point out really are these. When I said if you could graph this, you can graph its reciprocal function, the reason why I said this is because, well, what do we remember about secant? I believe secant would be the same thing as this, y equals secant of x. With our reciprocal identities, we say this as 1 over cosine of x. So what this means is wherever cosine of x is equal to 0 or doesn't have a height, then we'd say its reciprocal function would be 1 over 0 would be undefined. If cosine of x equals 0, so we say, all right, switching over to a red, we say where would this graph down here be at a height of 0? Well, we say everywhere it crosses this ground level kind of thing. So the first thing we're going to do is we're just going to drop in asymptotes wherever this is at ground level. That's always easy to do. You just say, well, where's it at ground level? Its reciprocal is going to be undefined. And as far as what the rest of the reciprocal looks like, if we shift over to like there we go, a golden, we say the reciprocal function is just a bunch of swoops that come up and touch this curve here. Okay? Here. And here. You know, we've got the edges here. They look like this. If we were to keep sketching outside, it would just be more and more swoops, and this graph repeats itself, of course. But the bottom line is this. That's how you would sketch the secant function. You would just sketch the reciprocal function first, 3 cosine 2x, and then you would just drop in your asymptotes where the original graph is on the ground, and then put in your swoops from there. That's all we would necessarily do. So things I want to point out about this, we'd say the domain. Domain, in terms of this, we say domain. In this case, is all real numbers x, such that x is not allowed to be. Now in this case, we can see that x is not allowed to be pi fourths. And we could also see that it was not allowed to be 3 pi fourths. But what I want you to recognize is this from here to here is a period of pi halves. I don't want to use period there. I should use this term. Is a length of pi halves. So we could say x is not allowed to be pi fourths plus pi halves k. Any number of pi halves on top of that is going to cause this to be undefined. And as far as the range goes, it was very important to note this up here, but we said the range is always y is greater than or equal to the absolute value of a, and y is less than or equal to the negative absolute value of a. So in this case, we say our a value is 3, so we say y is greater than or equal to the absolute value of 3, but also and y is less than or equal to negative the absolute value of 3, which it just means this, less than or equal to negative 3. Okay, so you can see from our graph here that our yellow graph from positive 3 to negative 3, 3 to negative 3 here, this span here, it never is in between there. Our yellow graph is always outside of this range. Okay, so we'd say that's how we're using this definition of range up here to get these values down here. But basically, you could just say by looking at the graph, well, it's all the y values except for the ones between negative 3 and 3. Between negative 3 and 3, I said, not at negative 3 and 3. They actually did reach a height of negative 3 and 3. So that's how you would sketch a reciprocal function with changing a and b values.